This next section is kind of a catch-all for various technologies that make your cluster work and do stuff. So we're going to talk about some technologies that are sitting there under the hood to manage all the resources on your cluster, like Yarn and Tez, which sits on top of Yarn. We'll talk about tools for managing jobs in your cluster like Oozie, and we'll talk about Zeppelin as well. And Hue, which is also another management console, kind of like Ambari. So we're kind of looking at these higher level tools now and technologies that kind of are the glue that makes your cluster work. So let's dive in and start by talking about Apache Yarn in more depth. Let's kick off this section by talking about Hadoop Yarn. It's a fundamental piece of Hadoop version 2 that manages all the resources on your Hadoop cluster for you. And it's one of those things that just kind of sits there under the hood doing its thing. You don't really think about it. And that's kind of the beauty of it. You know, it's doing some complicated stuff, but you don't have to worry about the details. Yarn stands for Yet Another Resource Negotiator. Cute little acronym. And it was introduced in Hadoop version 2. And the idea there was to actually split out the problem of managing the resources on your cluster from MapReduce itself. So in Hadoop 1, MapReduce was this monolithic thing where, you ran mappers and reducers, and the resource negotiation was just part of it. But with Yarn, they split out the resource negotiation part, which allowed the development of MapReduce alternatives, such as Spark and Tez, built on top of Yarn. And it turns out both Spark and Tez, by using directed acyclic graphs, can outperform MapReduce quite a bit. So that really does unleash a whole world of new possibilities and new performance that we couldn't have gotten otherwise. So thank you, Hadoop people, for splitting that out. Again, it just sits there running. It's things that are used by other applications. So like Spark and Tez are built on top of Yarn, but I can't really think of a reason why you'd actually want to be coding against Yarn directly yourself. I mean, odds are, whatever problem you need to solve, there are so many technologies in the Hadoop ecosystem at this point, I can't really imagine anything that you can't do using the tools that already exist. So don't reinvent the wheel if you need to. But if you really have some burning need to build a new application on top of Yarn, it is possible, and I will give you some pointers on how to do so. Where does Yarn fit in architecturally? Well, at the bottom of our stack here on Hadoop, we have HDFS, which is the cluster storage layer, the Hadoop distributed file system. So if you recall, that's just the system that allows us to spread out the storage of big data across your cluster by breaking it up into blocks that are replicated across the various nodes in your cluster. Now, Yarn sits on top of that storage layer. So Yarn is the compute layer for your cluster. And it can execute specific jobs or tasks or, application chunks, basically, if you will, that are depending on processing certain chunks of data that's on your HDFS cluster. So the whole idea of Yarn is to split up the actual computation across your cluster, whereas HDFS is splitting up the data storage across your cluster. And these two are pretty tightly integrated, actually, because Yarn tries to maintain data locality. If you try to execute a job that is specifically looking to operate on some specific blocks of data in HDFS, Yarn will try to align those on the same actual physical host as much as possible. So Yarn is basically what's managing the computing resources of your cluster, and HDFS is what's managing the storage resources of your cluster. Got it? Now on top of Yarn, we can write different applications such as MapReduce, such as Spark, and such as Tez. And these are Yarn applications that sit on top of the compute layer, which in turn sits on top of the storage layer. And if we go back to our original diagram from the very beginning of this course, you can also see that in a different form. So again, HDFS is kind of the foundation of Hadoop. Yarn sits on top of that, and there are actually alternative resource negotiators you can plug in as well that we'll talk about later. And things like MapReduce and Tez and Spark can sit on top of Yarn, which in turn sits on top of HDFS. And then MapReduce is also something that Pig and Hive can sit on top of, and actually Pig and Hive can go through Tez as well. So we have these different layers. So there's applications that run on top of the MapReduce Yarn application, which runs on top of Yarn, which runs on top of HDFS. So it's a kind of a Dagwood sandwich here of technology layers. But at the end of the day, it's all very scalable and all of it quite reliable, and it works really quickly. So as complicated as it is, it's very flexible, and it's enabled quite a bit of innovation in this space. So it's a good architecture. Okay, moving on. So this goes back to the original slide we had way back when in this course we were talking about MapReduce and how it works. So what we were really looking at here was just a specific example of how Yarn works, really. So if you remember, we had the client node that had the MapReduce script itself that would talk to our HDFS cluster directly in some cases. But that kicks off a request to the Yarn resource manager to actually spin up our MapReduce application. And the first thing Yarn does is request a node manager running on a specific node somewhere that has capacity to do so. And that would be running the MapReduce application master, which in turn would ask for more resources through Yarn, such as this node manager node, which is a physical computer running a couple of different MapReduce tasks. And maybe there's another computer over here running its own node manager that has just a single task going on. So each node can potentially have multiple containers running different processes. And these all are communicating to each other through HDFS to get the data that it needs. And that's how Yarn works. So if I was to put up a diagram of how Yarn works as opposed to MapReduce, it looks exactly the same. All I did was remove the name wherever it says MapReduce with application. Because really Yarn is just a general purpose framework for doing exactly that. You kick off an application from your client. A Yarn resource manager will then kick off an application master that runs on whatever node has capacity to run it. And then that application master is responsible for working with Yarn to spin up more nodes that have their own node managers that run specific application processes. So that's all Yarn is doing, is trying to make sure, it's trying to figure out where to run all these application processes, where to spin up these nodes, and how to evenly distribute the processing of that information across your cluster and do it in such a way that it minimizes data getting shuffled around your network. So it's both trying to optimize the usage of your cluster from CPU cycles and also trying to maintain data locality to ensure that a specific application process has as quick as access as possible to the data blocks that it needs from HDFS. So we talked about all this in the previous slide, but it's here for your reference. Again, the way Yarn works, your application talks to a resource manager to distribute the work to your cluster. And in a high availability Hadoop environment, there may be multiple resource managers that use Zookeeper to keep track of who the main master is at a given point. So just because you see a single resource manager in that diagram does not mean it's a single point of failure. There is a way to actually have redundancy there as well. We talked about data locality, and there are also different scheduling options you can specify when you're writing applications on top of Yarn. And these are usually configurable when you're actually running an application. So the three types of schedulers in Yarn are FIFO, which stands for first in, first out, capacity, and fair. So FIFO just runs jobs in sequence, first in, first out. So if you request to run an application in Yarn in FIFO mode, and then you request a second application, the second application won't start until the first one's finished. So it all just runs in sequence. Capacity means that if you're trying to run multiple applications at once on your Yarn cluster, they might run in parallel if there's enough spare capacity. So if you've kicked off a MapReduce job, for example, on top of Yarn that is only using a portion of your cluster, the capacity schedule can say, hey, I have some spare capacity here. If someone else wants to run another application, that can run at the same time on the other nodes. And the fair scheduler is a little bit different in that if you have a really big job running that is consuming everything on your cluster, but you try to get a small one and sneak it in, Fair might say, okay, I'm going to steal some resources back from this huge job just to give this small job a chance, because it's not really going to make a big difference in the grand scheme of things. So those are the different scheduling types you can configure with Yarn. FIFO, which just runs things in sequence, which is nice and simple and easy to understand. Capacity, which will make the best use of the capacity you have on your cluster. And Fair, which will actually try to give small jobs a chance, even if a big one is hogging the entire cluster. If you do need to write a new Yarn application, again, I don't see why you would need to do so, because there are so many existing Apache projects that can do anything you could possibly dream up, in my opinion. But even if you do need to write a new application, think about writing it on a layer that's on top of Yarn even. So why not, if you just need to take advantage of a directed acyclic graph as opposed to MapReduce, why not build it on top of Spark or Tez, which we'll talk about in the next lecture. But if you really need to do something, you have this really clever idea that's even better than a directed acyclic graph for managing resources, fine. There are frameworks you can look at like Apache Slider and Apache Twill that provide sort of a higher level abstraction on top of Yarn. Coding to Yarn directly is kind of tough, but there are some books on the topic as well if you need to go there. And like my little metaphor here, we like knitted up a little, I don't know what this is, a thing. Maybe it's crochet, I don't know. But the metaphor is we're building something with Yarn. Get it? I just amaze myself sometimes. That's really all there is to say about Yarn. There's no exercise here. There's no activity, because if you want to practice using Yarn, well, you've already done it. Every time you run MapReduce or Spark, or even, Hive or Pig, which runs on top of MapReduce, you've been using Yarn under the hood. So you've been using Yarn this whole time. All we're doing is pointing out what it's doing and the fact that it's there. So thanks, Yarn. We really appreciate you being there for us. So Up next, let's talk about Tez, which is an example of an application built on top of Yarn that makes things a whole lot faster.